The screen fades from absolute black to a singular, pulsating point of white light that vibrates with the low hum of a sub-frequency oscillator. We are looking at the seed of existence, the moment before the clock started ticking. There is a silence here that is louder than sound. It is the silence of the void, waiting for permission to exist. We like to believe that the universe is a machine, a grand clockwork mechanism governed by immutable laws that make sense, laws that are elegant and predictable. We comfort ourselves with the idea that if we simply dig deep enough, if we smash enough atoms and peer far enough into the cosmic microwave background, we will find a bottom. We will find a foundation of granite logic. But we have dug deep. We have looked into the abyss. And the abyss has returned a set of data so paradoxical, so terrifyingly unlikely, that it suggests our reality is not a solid construct, but a precarious glitch. We are standing on the edge of a precipice, staring down into the machinery of creation, and we have realized that the engine is broken. Or worse, it was never designed to be understood by the likes of us. This is an investigation into the three impossible questions, the three locked doors that separate science from madness. The camera drifts through the spiraling arms of the Andromeda Galaxy, moving at a speed that renders stars into streaks of luminescent paint. We arrive at the first impossibility, the question of fine-tuning. Consider the dials on the dashboard of the universe. There are roughly 30 distinct physical numbers that dictate how reality behaves. The mass of an electron, the strength of gravity, the speed of light. If you were to turn any one of these dials by a fraction of a percent, the engine would seize. Let us look specifically at the cosmological constant, the energy density of the vacuum of space, often represented by the Greek letter lambda. Theoretical physics predicts that this number should be enormous, a value that would rip the universe apart in a nanosecond, scattering atoms so far apart that they could never coalesce into stars. But when we measure it, the value is not enormous. It is near zero. It is precisely 120 orders of magnitude smaller than our calculations suggest it should be. That is the number 1, followed by 120 zeros. To achieve this value by chance is statistically equivalent to tossing a dart from the edge of the observable universe, a distance of 46 billion light-years, and hitting a target measuring 1 millimeter in diameter on the surface of the Earth. If this constant were slightly larger, the universe would have expanded too rapidly for galaxies to form. If it were slightly smaller, the universe would have collapsed back in on itself mere moments after the Big Bang. We exist on a razor's edge so sharp that it defies the laws of probability. It forces us to ask if the fix is in. Are we the winners of a lottery with odds so long that the math suggests the game is rigged? Or are we simply the only survivors in a multiverse of trillions of dead, sterile bubbles where the numbers came up wrong? The visual shifts to the cold, metallic interior of the Large Hadron Collider in Geneva. Superconducting magnets scream in the dark, guiding protons at 99.99% of the speed of light. We are now confronting the second impossible question, the measurement problem. For 300 years, we believed in an objective reality. We believed that a tree falls in the forest regardless of whether anyone is there to hear it. Quantum mechanics destroyed that certainty. At the subatomic level, matter does not exist in a definite state. An electron is not a particle, it is a wave of probability. A ghost that exists everywhere and nowhere simultaneously. It occupies a state of superposition until, and only until, it is measured. The act of observation forces the universe to decide what it is. This is not a philosophical metaphor. It is an experimental fact demonstrated by the double slit experiment. When we do not look, particles behave like waves, interfering with themselves. When we place a detector to see which path they take, they snap into behavior like solid bullets. The universe seems to know it is being watched. This implies a terrifying causal loop, where consciousness is not a byproduct of the universe, but the engine that renders it into existence. Without an eye to witness it, does the universe dissolve back into a haze of mathematical potential? If we are the observers collapsing the wave function, then we are not inhabitants of this reality. We are its architects. And if that is true, what happens when we blink? Camera pushes into the eye of a scientist, diving through the pupil, into the retina, into the firing neurons, dissolving into the electrical storm of the mind. We pull back to witness the timeline of the cosmos, a long, glittering ribbon stretching from the flash of the beginning to the cold dark of the end. This brings us to the third impossibility, the problem of entropy and the arrow of time. The second law of thermodynamics states that disorder always increases. An egg breaks and cannot be unbroken. Smoke disperses and cannot be regathered. The universe moves from a state of low entropy, high order, to a state of high entropy, total chaos. This makes sense for the future, but it creates a catastrophe when we look at the past. If we rewind the film, we must arrive at a moment of minimum entropy, a state of impossible order at the very moment of the Big Bang. The odds of the universe beginning in such a pristine, highly ordered state are calculated by the physicist Roger Penrose to be 1 part in 10 to the power of 10 to the power of 123. This number is so large that if you were to write a 0 on every proton in the observable universe, you would run out of protons before you finished writing the number. Why did the universe begin in such an unlikely, highly organized state? Who wound the clock so tightly? It implies that the Big Bang was not a random explosion, but a highly specific, highly calibrated initial condition. It suggests that time itself is an artifact, a trajectory chosen with deliberate intent. The screen goes dark, save for the faint afterglow of a dying star. These 3 questions form a triangle of ignorance that encloses our entire understanding of reality. The fine-tuning suggests design or an infinite number of failures. The measurement problem suggests that reality is a simulation rendered only where the player is looking. The entropy problem suggests that our beginning was a miracle of organization that defies the chaotic nature of nature itself. We are trapped in a room where the walls are made of questions we cannot answer. The constants are too precise. The atoms are too shy. The beginning is too perfect. We are left with the chilling realization that the universe does not make sense because it is not a natural phenomenon. It looks, behaves, and functions like a construct built for us, or perhaps a construct in which we are merely the subroutines trying to understand the source code. The hum of the oscillator returns, rising in pitch, becoming a deafening scream of data before cutting abruptly to silence.